Okay, this is the video on Nikhilam method of division. This is video number 8. In this video, I have brought out a skipped out details known as divide two-step division. Using the two-step division, I have removed the so-called magic part of the division. Here, you draw a line to the left of 3 digits. We just say divide the dividend by 1000. That's my first division. And also bring down the dividend digit in quotient line, which say that divide the dividend digit by my second division of 1 and then bring that down to the quotient line. Effectively, we still are bringing down the dividend digit to the quotient line, but at least we know we are dividing by 1. Okay, and I use the two-step division and proportional base numbers to compute recurring numbers, and the method is the same as Tirthaji has used. Okay. And also we have added some details in that section also. Instead of saying stick that remainder digit to the left of a quotient digit, we clarify why we do that, because remainder from the second division is proportional and proportionality is 10. That was my first division. So when we multiply remainder by 10 and add to the adjustment due to deficiency, remainder does come to the left. Okay, further the video goes on to show that this method of Nikhilam method and its sister method, transpose and apply method of division, are emulating straight division. Okay, now I'm going to look at contents here. Contents of the video are Nikhilam method, what that is, two-step division, and let's see what that is. That's we have been doing two-step division without ever telling anyone. So this method we're trying to bring out the two-step division which has been hidden, or we have been skipping the details so-called. Okay, we division by 2 and more digits, and compare that to recurring number method, because we are going to compute recurring numbers using that two-step division, and compare to straight division. And this method division is in fact is emulating straight division, and this discussion shows that it is. Okay, let's continue, and there's some examples. It's a Nikhilam method division, and let's see what that is. In this method, we take advantage of divisor being close to a base number. In the simplest terms, we divide by the base number and make adjustments for the difference, which difference is the deficiency. It's an indirect method. We do not divide by the divisor in question. Instead, we divide by chosen base number. So we achieve the results by dividing by another number. So this is an indirect method. Let's continue here. In this video, we'll consider only the divisors which are less than the base number. The divisors which are more than base number we will consider in the next video. In the previous slide, we talked about adjustment. Let's see what the adjustment is. Okay, we'll take example of divide by 9, and similarly we also would divide by 10 and see what differences adjustments I need to make. Continue here. Here is example of we have 10 numbers and we are going to divide by 9. Let's continue here. You know how we divide by 9? We extract our groups of 9 from this 10 number here. See what how many groups I got. Okay, let's continue here. So we got a one group here, and there's only one group, and remainder left over is 1. There's one group, that means quotient is 1, and so is the remainder is 1 here. Okay, let's continue here. That means when I divide 10 by 9, I got a quotient is 1 and remainder is 1. Let's continue and see what happens when I divide 10 by 10. Okay, so here same, we are going to divide by 10 now, and here 10, and I'm going to divide by 10. So how do you divide by 10? We're trying to subtract out groups of 10 here and see how many groups I got and what is left over. Let's continue here. So I got one group of 10 and nothing is left over. So that means quotient is 1 and remainder is 0. Okay, so quotient is 1, remainder is 0. Let's compare. We got quotient 1 and quotient 1. Remainder 1, remainder 0. That means when I divide by 9, I got remainder 1. When I divide by 10 here, I got remainder 0. So if I have to use divide by 10 to achieve divide by 9, I have to add 1 to the remainder. How to get, where to get 1 from? 1 come from here, and also the deficiency of 9 from 10. So deficiency of 9 from 10 is 1, quotient is 1, multiply 1 and 1 gives me 1, and that is my adjustment to the remainder. That means if I need to achieve divide by 9, using divide by 10, when quotient was 1, I have to add 1 to the remainder. Let's continue. I have now 30 numbers here. Okay, let's see. We are first going to divide by 9. Okay, so how do we divide by 9? We subtract our groups of 9. Let's do one group here, 2, 3. We got 3 groups. That means quotient is 3, and what's left over? 3. 1, 2, 3. That means quotient is 3 and remainder is 3. Okay, so quotient is 3, remainder is 3. Let's try divide that by 10. 10. So the same 30 here. I'm going to divide by 10. What do we do? Subtract groups of 10 to divide by 10. So let's see how many groups I have. Here is take a 9 here and 1 here. So one group. 9 here and 1 here. That's another group. 9 here and 1 here. Third group. So we have 3 groups of 10 here and there's nothing left over. So quotient is 3, remainder is 0. Difference is when I divide by 9, quotient is 3, remainder is 3. When divided by 10, quotient is 3, remainder is 0. That means that they're different of 3. 3 here and 0 here. If I have to use divide by 10 to achieve divide by 9, I have to add 3 to the remainder. And 3 comes from quotient 3 times the deficiency of 9 from 10, which is 1. 3 times 1 is 3. And that is what we need to add to remainder. If I have to use divide by 10 to achieve division by 9, I have to add 3 in this case and 1 in the previous case. Quotient was 1, adjustments was 1. Let's do example for divide by 9. Let's continue here. We are going to divide by directly by 9 and also indirectly by 9. Let's continue here. We get 1203. That's my dividend to be considered, and 9 is my divisor. Okay, let's continue. We'll set up same problem in indirect method. Indirect, we are going to divide by 10 to achieve a result of divide by 9. Let's continue. Same problem. Dividend is 1203. Dividend is 1203 and divisor is 9, which has a deficiency of 1 from base of 10. So we have a divisor is 9, which has a deficiency of 1 from the chosen base of 10. Let's continue here. So I take the first 2 digits here, 12, and divide by 9. I got 1, remainder 3. Okay, so how do you do that? So I say 1 in the quotient line and 3 in a remainder line. Let's continue and do the same thing using an indirect method. So we get same 2 digits. We have a 12 divided by 10. So I'm going to divide by 10 and try to achieve a result of divide by 9. So when I divide 12 by 10, I got 1, remainder 2. Okay, let's see how we do that. So we say 1 is my quotient and 2 is my remainder. I don't have to write another digit for remainder. 1 is my quotient and 2 is my remainder. Let's continue here. Now I have to make adjustments. Adjustment is deficiency times the most recent quotient digit. So D is a 1 and quotient is 1. My adjustment is 1. So I'm going to add 1 to the next remainder we just got. Okay. So I'm going to add 1 and that's going to make me a 3, which is the 2 plus 1. So I got 1, remainder 3. After added 1 here, 1 was this quotient digit was 1 and that's what I added to the next dividend digit. Okay, so I got 3 as a remainder when I divide 12 by 9. Okay, let's continue. Next digit in dividend is 0, which you have to consider next, and that's going to get appended to the right of 3, and I get 30. Okay, so we get 30 here. Now I'm going to divide 30 by 9. Let's see when I divide 30 divided by 9, I get 3, remainder 3. So let's see how we write that. So we get 3, remainder 3, and I crossed out 30 so that it does not confuse me anymore. So I divide 30 by 9, I get 3, remainder 3. Let's continue. And now we do same thing. We add a 0 here, we had next 0 here, and we bring that down, and we did. So I got 30 here, just like we got 30 in the direct method. Indirect method also we have a 30 at this stage. Okay, this is my working dividend. Okay, let's continue here. I'm going to divide by 10. I'm going to divide by 10, divide by 10. 30 divided by 10 is 3, remainder 0. Let us see how we write that. Here's my quotient 3, remainder 0. Quotient 3. I divide 30 by 10. I got 3, remainder 0. Quotient is 3 and remainder is 0. Okay. Now I'm going to make some changes so that I can affect the division by 9. So 30 divided by 9 is 3, remainder 0 plus adjustment. What adjustment is? Q, most recent quotient digit, and plus times the dividend. Times the deficiency. Deficiency is 1 and quotient is 3. 1 times 3 is a 3. So I got to add 3. Okay, let's see how to do that. So I just added 3 here. On the next dividend digit, become 3 here. 0 plus 3 is 3. 3 are 3. And I crossed out this previous. Okay, let's continue here. We do so far we had completed 30 divided by 9, which is 3 remainder 3 on the direct side, and also 30 divided by 9 is 3 remainder 3 on the indirect side also. We use first 3 digits of the dividend. We have used first 3 digits of dividend. Okay, and we have 3 in the remainder and we have 3 in the remainder. So now let's continue here. I'm going to get, we have this 3 here and this 3 here. We're going to bring down this 3 to next to the remainder 3 and I got 33. Okay, let's continue here. Okay, we have 33 now in the next dividend, working dividend. 33 I'm going to divide by 9. So we got 33 divided by 9 is 3, remainder 6. Okay, so we got 3 here, remainder 6, and I crossed out the 33, the previously working dividend, and so I got 3 as a quotient, remainder is 6 when I divide 33 by 9. Okay, let's continue here. Now I have 3 right here, and I'm going to append the 3 here, make it 33. With next 3 from a dividend, I'm going to get in it 33 here. Okay, we got 33. Now I'm going to divide by 10. When I divide 33 by 10, I have a 3, remainder 3. Let's see how we write that. We say 3 as a quotient, and this 3 is the remainder. Okay, let's continue here. Then I got to make adjustments for the deficiency times the quotient digit, okay, which is so has 3 already remainder. Adjustment is 3 times 1, which is 6. 3 plus 3 is 6, so we got 3 remainder 6. So I'm going to add 3 to the next remainder. This was this remainder. I'm going to add 3 to this remainder here. Okay, let's continue here. So I added 3 here, becomes 6. I crossed out this 33 here so that it does not confuse me anymore. So I got an 3 as a quotient, remainder as 6. We have a 3 as a quotient here, remainder is 6. Okay, so when I divide by 9 using indirect method, I also get the same results. Let's continue here. That means answer is 1203 divided by 9 is 133 right here, remainder 6. 1203 divided by 9 is 133, remainder 6. Okay, let's revisit this example here. Okay, question: is that not the method 2 involved? There are two answers: yes and not really. Let's go ahead and try to explain. Let's take the yes answer first. Okay, but I have to show you all the details, and you should understand details. So it's a little complicated, involved, but it I have to show you the details, and that's how come it's little involved. Okay, let's continue here and let's do the not really part. Not really part of the answer is in VM we skip details and combine steps. When you do that, it's not involved anymore. Let's see what I mean by that. Let's continue here. So you get a 1203 and divide by 9. We'll take and deficiency is 1. So we'll take this example again. 1203 divided by 9 and deficiency is 1. Let's see what we have to do here. Okay. First, there's 1 here. We're going to divide that 1. There's 1 here in leftmost position. Okay. That's what we're going to concentrate on. And we use the same one in Q1 position. So this one is my quotient now. First quotient Q1. Okay, let's continue here. So we got a 1 in quotient. Okay, now what do we do next? Add that one, this one here in Q1 position to the next dividend digits. Next dividend digit is 2. We're going to add 1 here. Okay, let's continue here. So we added 1. Okay. Okay, let's continue. Now 2 plus 1 is 3. Okay, I'm going to use the total of 3 in Q2 position. 2 plus 1 is 3, and now my next quotient digit is 3. Let's continue. Okay, now I'm going to add this 3 to the next dividend digit. Okay, 3 plus 0 is 3. Okay, we're going to add that. Okay, that now I have added 3. This 3 here added to next quotient digit, next dividend digit. This quotient digit here added to next dividend digit. Okay, let's continue. Now I have a total of 3 in here. That's this 3. 0 plus 3 is 3. I'm going to use that for Q3. Okay, let's continue here. So I have my third digit in quotient is 3, and that was 0 plus 3. Okay, let's continue here. Add the Q3, this 3 here, to the next dividend digit. Okay, so we added that 3 plus 3, and that may give me remainder of 6. That means remainder of 6 here. So 1203 divided by 9 using the Nikhilam method is 133, remainder 6. Okay, let's continue. That's all, folks. It all adds and there's no divide. So we did a division using adds only, no divides. Okay, we got 1 in dividend, use that quotient, add that to next dividend digit, got a 3 in the quotient digit, add that to next dividend digit. Your total here 3, use that next quotient digit, add that to the next digit, and last one. Let's go discuss what two-step division is. Let's find out. I have been talking about two-step division. Let's see what it is. Okay, let's continue here. We're going to some examples here. First example is 23 divided by 16, which I know is 1, remainder 7. Let's continue here. And I'm going to do two-step division, where instead of dividing by 16, I'm going to divide first by 2 and then by 8, because 16 is equal to 2 times 8. Okay, this is my two-step division. So let's see what's happening here. Okay, so when I divide 23 by 2, this is my first division. I got 11, remainder 1. Let's continue here. Now in subsequent division by 8, remainder stays invariant. We don't divide it further. We would divide the 11 here. Let's continue here. So 11 divided by 8 is 1, remainder 3. So I first divide 23 by 2. I'm trying to do 23 divided by 16. I got 11, remainder 1. Then take the quotient of the first division and divide that again by 8, which is my second division, and I got 1, remainder 3. Let's continue here. Now we have two remainders, 1 from first division and 3 from the second division. And we were looking for one remainder of 7. Okay, let's continue. Do another example here. Now I'm going to do example of 183 divided by 100, which I know is 1, remainder 83. Okay, let's continue. Now I'm going to use these two steps. 100 is equal to 50 times 2. So I'm going to divide first by 50 and then by 2 to achieve a division by 100. Let's continue here. So 183 divided by 50 is, I can subtract out 3 groups of 50 from 183. So I get 3 as a quotient, and remainder after I subtract out 3 groups of 50, I have 33 left over, and that is my remainder. So next I'm going to divide by 2. I'm going to divide this 3 here, which is quotient from first division, and I would leave the remainder untouched. 3 divided by 2 is 1, remainder 1. Okay, let us see what happened. Now we have two remainders again, 33 from first division and 1 from the second division. And we were looking for one remainder of 83. Let's continue. Another example, please. Let's try 867 divided by 30. If I did that, I need to extract our groups of 30 from 867. I can extract out 28 groups of 30 from 867, and I have 27 left over. So I quotient of 28, remainder of 27. So let's see how we're going to do two steps. I'm going to do two steps, like 30 is equal to 10 times 3. And my first step division is by 10, and second step is by 3. Let's continue here. When I divide 867 by 10, I got 86 remainder 7. Now I'm going to further divide 86, the quotient here, and I would leave the remainder alone, okay, by the second division, 3. Let's divide that. And divide 86 by 3, I got 28 remainder 2. Let's continue. We have two remainders of 7 from the first division and 2 from the second division, and we were looking for one remainder of 27. Let's go back again. Quotient is 1 and we go to quotient 1. Quotient is 1 here, we have a quotient, we got a quotient of 1. Quotient was 28 here, we got quotient of 28. Now issue is of the remainders. Let's see what's going on here. In second division, I'm looking for this example in first one. 11 by 8. 8 is a proxy for 16. In fact, we are dividing 22 by 16. The only thing first division did, the remainder which we say we are not going to divide again, we had taken out 1 from 23 and left it 22, and we are dividing 22 by 16, but instead of dividing 22 by 16, I'm going to divide 11 by 8. Why? 8 is smaller number and it's easier to divide. Okay, so in fact we are dividing 22 by 16, which gives me 1 remainder 6. In here, the only thing we did is that we say we would leave the remainder alone, so we have just what we did is subtracted 33 out from 183. Okay, so the second division here is dividing 150 divided by 100, which gives me 1 remainder 50, and 50 plus 33 is 83. Okay, so this 2 here is a proxy for division by 100. If we were to make 2 as 100, then 3 become 150. Okay, that's 150 over 100 is 1 remainder 50, and 50 plus 33 is 83, what we're looking for. In the third example here, we are dividing by 10. 10 is a proxy for division by 30. That means that we are dividing, we're dividing by 3 in second division. 3 is a proxy for division by 30, and that means we are trying to divide 860 divided by 30, which is 28, remainder 20. Okay, so remainder in the second division is proportional, and proportionality is given by the first division. Remainder here is proportional, and proportionality is given by the first division. Remainder here is proportional, and proportionality is given by first division. So this 3 is 3 times 2 is 6. 6 plus 1 is 7. This 1 is 1 times 50, which is 50. 50 plus 33 is 83. Okay, this 2 here is proportional. 2 times 10 is 20. So this is nominal value of 2 has effective value of 20. 20 plus 7 is 27. Let's continue. When we divide by 2 in computing 1 over 19, we apply adjustment due to deficiency as if we were dividing by 20. In fact, we are. So when we do a second division, we in fact are trying to divide out by not by the proxy divisor. In fact, we are trying to divide that out by proxy divisor times the proportionality. Okay, let's continue here. This is what you need to remember, that in second division, the remainder, this remainder here, this divisor here, and dividend, these 3 items are proportional. Okay, let's continue here. Final remainder in first case is 3 times 2 plus 1 is 7, and the other case is 1 times 50 plus 33, in second case 83. In third case it is 2 times 20 plus 7, 26. Let's use the two-step division I have been talking about. We just showed what it was. Let's continue. Example is 979 divided by 29. Okay, we'll use a proportional base of 30, which is 1 more than 29, and deficiency is 1. We got that from base 39 minus 29, and I get This one here using the sutra, all from 9 and last from 10. So we have a Nikhilam method of division, and I got Nikhilam from, I get a deficiency of 1 for using sutra, all from 9 and last from 10. Let's continue here. We'll use two-step division. 30 is equal to 10 times 3 and proportionality is 10. I used a base number as a first division and the factor of that as second division. Okay, let's continue here. So example is, this is where I lay down my problem here. The dividend here 979, here is my divisor, and here is my deficiency, and my second division is 3, first is by 10. Let's continue here. First I'm going to divide by 10. That's what we said. We are going to divide by 30 and do so in two steps. First by 10, which is a natural base number, and later by its factor required to complete the 30 here. Let's continue here. We just draw a line to the left of one digit, and so we divided by 10. We divided by 10 because I'm trying to do a two-step division. 10 times 3. Okay, I divide by 10. Now I have to divide by 3 and make the adjustments for the deficiency. Let's continue here. So now I have 9 here, and we have to divide by 3. 9 divided by 3 is, I got quotient 1, first quotient digit is 3. 9 divided by 3 is 3, remainder 0. So my first quotient digit is 3. I got a 3 here. Okay, let's continue here. Now this is the adjustment for the add Q1 to next dividend digit. So that is my adjustment due to deficiency. Okay, so we are going to add 3 to the next dividend digit. Okay, let's continue here. We just wrote down 3 here. Okay, now we have 10 in this column here. In column here, I have 7 plus 3, which is 10. Now I'm going to divide this 10 by 3, get me 3, remainder 1. Okay, so we get 3 here and remainder 1. Let's see what we do with the remainder 1. Okay, remainder 1 is proportional, and proportion is second division. I'm in a second division now. I did first division here and a second division, so it's proportional. Proportionality is 10. Okay, so this 1 is my nominal remainder at this stage, and 1 times 10 is my effective remainder at this stage. Let's continue here, and there's other adjustment here because of the deficiency here. So that is equal to Q2. Okay, and that's 3. So I had add two numbers, 10 plus 3, to the next dividend digit. Okay, let's continue here. So I got to add 13 here, and then add 9 plus 13 in, this is my remainder column section here. Remember that we told you before that we don't touch the remainder in, we don't further subdivide divide the remainder. So this remainder we don't divide anymore. So 9 plus 13 is 22. Okay, remainder is 22. Okay, so what do we got? 979 divided by 29 is 33 right here. Remainder 22 right here. Okay. Let's come back to division by 9. Let's look at example here. 110212 divided by 9. We'll use a base number of 10, which is 1 more than 9, and deficiency is 1. We get deficiency of 1 using sutra all from 9 and last from 10 on the divisor 9. Okay, let's continue here. We got two-step division, and 10 is 10 equal to 10 times 1. First division is by a natural base number, and the second division is by the factor needed to come back to the base number here and adjust for deficiency. Deficiency is 1. Let's continue here. Here's my problem here. 110212 in the dividend, 9 as a divisor, and deficiency of 1, and base number is 10. Let's continue here. So first we say we are going to divide by 10. Let's go divide by 10. We just did. If I divide 110212 by 10, I get a 11021. Remainder is 2. Continue here. Now we're going to divide by 1 now, one digit at a time. we're going to divide leftmost digit 1 by 1 by the second division. Okay, so the 1 divided by 1 is 1. Okay, now there are adjustments here. Multiply q1 by, which is 1, by 1, which is deficiency, and 1 times 1 is 1, so we will add that to next dividend digit. So we would add this 1 times 1 equals 1 to the next dividend digit. Let's continue here. So in next dividend digit we have 1 plus 1 is 2. Okay, now we got a total of 2 here, and we divide that by 1 to get a second quotient digit is equal to 2. Let's continue. So I got 2 here. When I had 1 here, we added 1 to next dividend digit. Now we got 2 here. We are going to add that to the next dividend digit. Okay, let's continue here. Add q2 to next dividend digit, and then 0 plus 2 is 2, and that's also my quotient digit, because when divide 2 by 1, which is my second division, I got 2. Okay? So I got 2 here. 0 plus 2 is 2. 2 come from here. This 2, we added the same 2 here. And 0 plus 2 is 2. I got a quotient. Next quotient digit is also 2. So I'm going to add this 2 to the next digit. Add q3 to the next dividend digit to get 2 plus 2 is 4, and the same is quotient. Okay? So 2 plus 2 is 4. That's my next quotient digit. And now I'm going to add this quotient digit to the next dividend digit. Add q4 to the next dividend digit. So 4 plus 1 is 5, and I get a quotient of 5. 5. Okay, so okay, 1 plus 4 is 5, and I get a quotient of 5. Let's continue here. Now I'm going to add this quotient digit to the next dividend digit. Add q5 to the next dividend digit to get our remainder of 7. 2 plus 5 is 7. Okay, let's continue here. That means that 1, 1, 0, 2, 1, 2 divided by 9 is 1, 2, 2, 4, 5, remainder 7. 1, 2, 2, 4, 5, remainder 7. Let's continue here. Now we have gone to details. From now on, you can skip details and just keep adding. Okay, continue. Let's see if there's some issues with dividing by 9. Okay, issues. In dividing by 9, we can have the following issues. Okay? Excess remainder, which is remainder is at least more than 8, or at least equal to or greater than 9. Okay, so if it's more than 8, and then there would be issue, there's too much of a remainder in division by 9. Okay, let's continue here. And also we can get multiple quotient digits. Okay, we're adding, so a quotient digit could be have more than one digit, because by adding numbers together we can all overshoot. Okay, let's see what, and we'll see our combination of both of the above. Okay, so either can get a larger remainder, or we can have quotient digits which consist of 2 digits. Okay, let's continue. Quotient values in some position has more than one digit. Okay, or combination. So let's look at some examples here. This time we'll do examples of when we have a larger remainder. Okay, let's see. Here are my 3 example here. 1, 2, 2, 1, 3 divided by 9. The first example. 2, 2, 2, 3, 5 divided by 9. 3, 4, 2, 8 divided by 9. Okay, let's continue. So let's divide by 10. So we just did. Okay. Now we have divided 1 and make adjustments. Okay, so which is just adding. We just keep adding them. Okay. Now adjust for deficiencies here. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 1 is 6, 6 plus 3 is 9. Okay, let's continue here. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 3 is 9, and 9 plus 5 is 14. Let's continue. Next example, 3 here. 3 plus 4 is 7, 7 plus 2 is 9, 9 plus 8 is 17. Okay, let's continue. So express remainder as a fraction. Okay, so that means this is 9 divided by 9. We were dividing by 9. This is 14 divided by 9, and this is 17 divided by 9. Let's continue here. These are improper fractions here. So we resolve them. This is 1, remainder 0. This is 1, remainder 9. This is 1, remainder 8. Let's continue. So that gets me 1, 3, 5, 7, remainder 0. Okay. 1 more than 6 is 7, and remainder was 0. Here is a What remainder was 5, and 1 more than 2469 is 2470. Here there is a quotient 1 again, so 1 more than 379 is 380, and the remainder from 17 divided by 9 is 8. Let's continue here. So here is my result. 1 2, very first one, 1 2 2 1 3 divided by 9 is 1 3 5 7, remainder 0. Next is 2 2 2 3 5 divided by 9 is 2 4 7 0, remainder 5. 3 4 2 8 divided by 9 is 380, remainder 8. Let's see what happens if we have a larger quotient digits. We have a more than one digit in a quotient position, and let's see how we are going to handle that. Okay, there are two ways to handle such cases. One of them, continue with the larger digits, more digits than one, okay, in a position, okay, and anticipate a carry and apply. Okay, so example we would do it twice is 56709 divided by 9, and again same example, 56709 divided by 9. Continue here. First we would divide by 10. Our base number is 10, and then we have a two-step division, first by 10 and then by the other factor, which is 1, and then we would make adjustments. So we just did by 10. Now we're going to make it divide by 1 and make adjustments, which is just keep adding the digits together. Okay, let's see. So on left, continue with larger numbers. We will get a more than one digit, and we would get in a continue that. Okay, let's continue here. So I got 5 here. Then we got 5 plus 6, 11. 11 plus 7, 18. 18 plus 0 is 18. 18 plus 9 is 27. Now in this case here, let's on the right we will anticipate a carry. 5 plus 6 give me 2 digits, not 1. So I would have a there would be carry. I will anticipate the carry and use a 6 instead of 5. So I got 6 here because 5 plus 6 would have given me 11, which is more 2 digits, and that is means I got a carry to the left, so I just use that carry. Okay, now I got 6 here on this position here. 6 plus 6 is 12. 12 is 2 digits, and I use the carry to the left. 12 is 10 plus 2. 10 gives me a carry to the left of 1, and I already used that carry. So from 6 plus 6 is 12. I only got left with 2 in a next quotient position. Let's continue here, and then 2. Then I get 2 plus 7 is 9, and 9 plus 0 is 9. So we'll get 9 here, third quotient digit, and 9 here on the fourth quotient digit. Let's continue here. So I get 9 and 9. Now I'm going to add this 9 to the next 9 here. So that is I get a 18 remainder. Okay. So let's go start to resolve the carries on the left here. Okay, let's see what I do. So first we get 8 here, then we will take this carry 1, add to the next digit 8. Okay, so there I get 9 here. Now I'm going to take this carry here. I'm going to take this carry here, add to the next digit here 1. So I get 2 here in the next digit here. And now this carry here, I am going to add to the next 5 here. So 5 plus 1 is 6. So I get 6 here. And remainder is 27. Okay, let's see what we do next is, now I have a improper fractions here, 27 divided by 9, and improper fraction here, 18 divided by 9. 27 divided by 9 is 3, remainder 0. I can extract out 3 groups of 9 from 27, and nothing is left over. And extract out 2 groups of 9 from 18, and nothing is left out. Okay, so there is 3 remainder 0 here, and 2 remainder 0 here. So we'll add the quotient to the quotient, and let's see what happens. So that gives me 6301, which is 6298 plus 3 is 6301, remainder 0. Same thing, 6299 plus 2 is 6301, remainder 0. Okay, and we update the quotient. We resolve the fractions and add up to the quotient, and this is what I got: 6301 remainder 0, 6301 remainder 0. Let's consider an example of division by 8. Let's continue. The example is 1, 2, 3, 4, 5 divided by 8. See, my imagination for the dividend 1, 2, 3, 4, 5, okay, divided by 8. And deficiency is 2. We got deficiency 2 from R from 9 and last from 10 of 8. And that is the sutra, and that's the Nikhilam sutra. Okay, and the two-step division is my base number is 10, is 10 times 1. First division by 10, which is natural base number, and next division by 1, which is the other factor of the base number. Let's continue here. So here's my dividend 1, 2, 3, 4, 5. And here my divide by 10, okay, because my first division is by 10 and second is by 1, and adjustments is for deficiency of 2. Let's continue here. So we just divide by 10, okay. Now divide leftmost digit by 1. So leftmost 1 divided by 1 is 1, okay. Now adjust for deficiency, which is D deficiency times Q1, which 2 times 1 is 2. So adjust for deficiency. So we got 2 here. 1 times the deficiency. 2. 2 plus 2 is 4. We do, okay, and then add the digits in the next column. 2 plus 4 is 4. We divide by 1, which is 4. Okay. Okay. Now here's my deficiency here. Adjust for deficiency again. 2 is my deficiency. 4 is my most recent quotient digit. 2 deficiency and most recent quotient digit. 2 times 4 is 8. This is my adjustments. So next positions we have 3 plus 8 is 11. In next dividend positions we have 8, 11. Okay. So we got 11 here. So that's my quotient in that position here. Okay. Let's continue here. Now we are going to add twice as much. 2 times 11, which is 22, to the next dividend position. Okay. So I got 26 here, 2, 6 in this position here. That's my quotient now. Okay. So I'm going to add 26 times 2 to the next dividend position. So adjust for deficiency, which is 2 times 26 is 52. We add that to last dividend position. Okay. So there I got 57 in the remainder column now. So that's what we got. Okay. Now we have to resolve the carries. Okay. So I got 6 here, and 2 plus 1 is 3 here. Then 1 plus 4 is 5 here. Okay. Next. And this 1 here, there was nothing carried from the right. So we got 1, 5, 3, 6. Okay. So far we have a 1, 5, 3, 6, remainder 57. Okay. Now resolve the remainder. So remainder, it gives me a improper fraction because 57 by 8 is more than 1. It's improper fraction. Improper fraction. Okay. So I got an, and my 57 by 8 is 7, remainder 1. Okay. So add 7 to 1536. I got 1543, remainder 1. Okay. Final answer is 1, 2, 3, 4, 5 divided by 8 is 1, 5, 4, 3. Exercises now. 18149 divided by 9. 11631 divided by 9. 20194 divided by 9. 14827 divided by 8. 10319 divided by 9. 12871 divided by 8, and some more. Let's do a two-digit divisors here now. Example is 100 divided by 19 to 5 decimal places. We'll divide by 19 and also decimalize the result. Let's continue here. So sutra is by 1 more than 1 before. By 1 more than 1 before, 9, 10 is the divisor, one more than that is 20, and 20 is a proportional base. Two-step division is we divide by 20, but we'll divide in two steps. First step is 10, second is 2. First step is always natural base number, and second step is the other factor so that I can divide by my divisor, which is 20. Okay, let's find out my base number. Divisor actually is 19. We are dividing by 20 indirectly. Okay, deficiency is 1, which is deficiency of 19 from the chosen base number of 20. Proportionality is 10. 10 is my first division. Okay, let's continue. So let's set up a problem here. 100 divided by 19, and my deficiency is 1. Let's continue here. First we'll divide by 10, just like we said we would divide first by 10. Okay, so I just did. Decimal point go right here. Okay? Continue here. So now I get 10, we go divide by 2, which give me 5, remainder 0. So if I try to divide 1 by 2, doesn't seem to work out. So we just use it 2 digits to start with. 10 divided by 2 is 5, remainder 0. Okay, so here's my 5, decimal point at the line here. Okay? And remainder is 0, so there is no adjustment for the remainder, but there is adjustment for the deficiency. Okay, let's continue here. Adjusted deficiency is 5 times the deficiency 1. Deficiency 1, 5 times 1 is 5. We are going to add 5 to the next dividend digit. That's my deficiency. Okay? So we just did. So I get 0 plus 5 is 5 now. Okay, I'm going to divide 5 by 2. 2 is my second division. Okay, and when I divide 5 by 2, I get 2, remainder 1. Okay, so I get 2 here and remainder 1. 1 is my nominal remainder at this stage, and effective remainder is 10 times 1, which is 10. Okay, proportionality is 10. This is my second step of division. All right, so I'm dividing by 5 by 2. In fact, we are trying to divide 50 by 20. 2 is a proxy for division by 20. So anyway, this is 2 is my quotient, which I just got here. Remainder is 1, which is a nominal value of the remainder, and the effective value of that is this is my nominal remainder, and effective value of that is 10. Okay, so we just added 5, this 2 here, so we would 2 remainder 1. So this is the adjustment due to the remainder. Okay, 10. Okay, and there is also adjustment due to this deficiency here too. Okay, so total adjustment in the next column is 12. 10 for the due to remainder, and 2 due to the deficiency, and 12. Now see, the 1 from remainder comes to the left of the adjustment due to the deficiency, and 2 is also the quotient digit here. Let's continue here. Okay, remainder, nominal remainder 1 comes to the left of the 2, which is the quotient digit here. Let's continue here. So now I'm going to add this 12 to the next dividend digit, and let us continue. Let's continue with the problem here. So far we had 100 divided by 10, then did 1 division 5, then add the 5 here, then divided by 2, and this is the adjustment due to is 10 plus 2 here, 2 from the deficiency, and the 10 from the remainder here. Let's continue now. Okay, now we are going to divide this 12 here. We have to divide it by 2, which is my second step division, and I get a 6, remainder 0. Okay, 6, remainder 0. There are no adjustment from the remainder, but there are adjustments from the 6 because of a deficiency. So we would add 6 to the next dividend digit. We get 6 times 1, which is equal to 6. Okay, let's continue. Adjust for deficiency is 6 times 1 equal to 6. Okay, so we add the 6 now. Now we have to, in next dividend column we have a 6. We divide by 3, which is my second division. 6 divided by 2 is 3, remainder 0. So no adjustment for the remainder, but I have a quotient here 3 and I have a deficiency 3. So there is an adjustment due to the deficiency caused by the quotient of 3. Let's find out. So we would adjust for deficiency, which is 3 times 1. 3 quotient digit and 1 as a deficiency of 19 from 20. Okay? So I got to add a 3 to the next digit here, next dividend digit. So 3, now we have 3 in this, in this column we have a 3 dividend value of 3 in this column here. We divide 3 by 2, we got 1, remainder 1. So now we have a remainder now. There are two adjustments now, one because of the remainder 1, another because of the quotient 1, and deficiency is 1. Let's see what we do here. So we did divided by 3 divided by 1, we got 1 here. Okay, now the adjustments for the next column. There are two adjustments, one due to the deficiency and another due to the remainder. Okay, adjustment due to deficiency is 1 times 1, which is equal to 1, and 1 due to remainder is 1 times 10. P is a proportionality here. 1 is my nominal remainder and 10 is my proportionality, and 1 times 10 is equal to 10. That is my effective remainder at this position, and total adjustment is 1 plus 10 equals to 11. We need to add 11 to the next dividend position. Okay? We just did, and then I have 11 in this column here for the dividend. So I divided by 2, my second division. 11 divided by 2 is 5, remainder 1. 5 is my next quotient. Let's go use 5 quotient now. Now there are two adjustments. One because of the quotient 5 and deficiency 1. Another because of the remainder 1. Okay. Adjustment is 1 times 10. Remainder 1 is a proportional. It's a nominal value. Its effective value is 1 times 10. And this is the adjustment for the deficiency. 1 times 5, 1 times 10 plus 1 times 5 is 15. So 15 is the adjustment for the next dividend position. Okay, we got 15 here. Now I got to add 15. We have 15 in this column here. I got to divide by 2. So the 15 divided by 2 is 7, remainder 1. Okay. So I have so far 5.263157. Okay, let's continue here. So we had there's 6 positions now. 1, 2, 3, 4, 5, 6, and we were looking for 5 places. So we just round up the 5 here, drop 7. So 100 divided by 19 is 5.26316 up to 5 places. And if you were to do 1 over 19, that would be 0.0526316 and so on. Okay. Let's try another example. This time we would divide 3 by 39. Let's continue here. So here is example. Compute 3 divided by 39. Let's continue. So sutra we would use is 1 more than 1 before of 39, which is 40. A deficiency of 39 from 40 is 1. Let's continue. So we would still do two-step division, which is 40 is equal to 10 times 4. We would divide first by 10 and then by 4. Proportionality is 10, which is my first division. Let's continue. This is the way we set up the problem here. 3 as a dividend and 39 as a divisor, and its deficiency is 1 from the chosen base 40. Let's continue. We will first divide by 10, just like we said we would, and we are going to divide by 10. Let's continue here. So we just divided by 10, and decimal point is along this line here. So this is my decimal place here. So we just change 3 to 0.3 by dividing by 10. Let's continue. So now we have to divide by the second division, which is 4. I got 3 divided, when I divide 3 by 4, I got 0, remainder 3. Let's continue. How do we write that? Okay, so I got a 0 point and a 0. Okay, Okay. Now we have to make adjustments for the quotient or for deficiency. Quotient is 0, so adjustment due to deficiency is 0. And the remainder is 3, which is proportional, and proportionality is 10. Remainder 3 is from second division. First division was by 10 and second was by 4. So this remainder is from second division. It's just like dividing 30 by 40. Okay, so 3 by 4 is 0, remainder 3. 3 is the remainder from second division. Let's continue here. Adjustments are, because deficiency is 0, because quotient is 0, 0 times 1 is 0. For remainder is 3 and proportionality is 10. 3 times 10 is 30. Okay. So next dividend position value is 0 from the dividend. Nothing in here in the dividend column row here. 0 from deficiency, we just computed 0 here, plus 30 from remainder, what we just said was. Okay. So it is 30. Okay, this is how we're going to show 30 here. So next dividend position is 30. My next working dividend is 30. How we did that? We got 0 from the quotient and with 3 from the remainder, and 3 was worth 30, so from proportionality as such it goes to the left of 0. 3 goes to the left of 0 because it's 30 here. Okay, and 0 is a part of the answer. This 3 is my scratch pad number, which I am using to continue to divide in the same line here. I'm going to divide in line, in same line, and so I use 3 to the left of 0 to make it 30. That's my next working dividend. Okay, so next division is of 30 divided by 4. So I would keep dividing in same line now. Okay, from now on I would divide in line. Okay, so when I divide 30 by 4, I get 7, remainder 2. Okay, next dividend digit is 7 because of the quotient digit. 7 times 1 is 7, and plus 20 from the remainder. 2 times 10. Okay, 2 times 10. 20 plus 7 is 27, and this, so this is my next working dividend, and I would divide 27 now by 4. So okay, let's continue. So that's give me 6, remainder 3. When I divide 27 by 4, I get 6, remainder 3. 6 is my quotient digit, and deficiency adjustment because of that is 6. And 3 was my remainder digit, which is proportional. So 3 times 10 is 30, plus 6 is 36. This is my 36 next working dividend. Okay, now let's go start. Now I need to divide it. See, the dividend number has zeros after this first 3. Okay, there's no contribution from a dividend, and division continues through the remainder. So this is my remainder, or this is my next working digit. This is my total remainder. This is 30 from the uh, remainder and 6 from the adjustment due to deficiencies. So when I divide 36 by 4, I got a 9, remainder 0. So this is how much to 9, remainder 0. So I'm going to divide 9 by 4. That would give me 2, remainder 1. Okay, so I got 2, remainder 1. So this is 2, remainder 1 is proportional, so 2 plus 10 is 12. This is 12 here, and this is my next working dividend. So from now I'm going to divide 12 by 4. That gives me 3, remainder 0. So I got 3, remainder 0. Okay, quotient is 3, remainder is 0. Contribution because of quotient is 3 times 1, and that because of remainder is 0 times 10, so it's 0, 3. Now need to divide this 3 here by 4, my second division. Let's continue. That gave me quotient of 3, remainder of 3. Okay, so 0, remainder 3. That's what we had here. That's what we got here. Now after that it would start to repeat. Okay, so that means the quotient digits have started to repeat. This 0, remainder 3, and 0, remainder 3. Okay, let's continue. The quotient has started to repeat. That means 3 divided by. Alright, let's compare with recurring numbers now. In the previous slides, we have computed 100 divided by 19, 979 divided by 29, and 3 divided by 39. Let's continue here. In 100 divided by 19 and 979 divided by 29, we use multiple lines to divide. In 3 divided by 39, we divided in one line and we call that in-line division. Tirthaji uses in-line division in computing recurring numbers. Okay, let's continue. So Tirthaji uses the same method as we used in computing 3 divided by 39 in computing recurring numbers. Let's continue here. Now let's try to compare that with what Tirthaji would do. For dividing by 19, we added 1. And your sutra was by 1 more than 1 before. 1 to 19, that gives me 20. Then we use that two-step division, and to divide 20 in 2 steps, we divide first by 10 and then by 2. 20 is a proportional base number. So first division is by natural base number and the second division is by the other factor of the proportional base number by 2. And that's how we get a 2. First we add 1 to 19, then we say we would do two-step division. So I get 10 times 2, 2 is my second division. This is how we got a 2 from 19. Let us see what Tirthaji does to get this 2 here. Tirthaji uses 1 more than 1 before 9. So that means 1 more than 1 before 9. Before 9 was 1, so he's trying to get a 1 more than of 1, which is 2. So we did get 2 through 20 and two-step division, and 2 was my second division, and Tirthaji got 2 from using this modified sutra, 1 more than 1 before 9 of 19. Let's continue here. We change 100 to 10.0 and 3 to 0.3 by dividing by 10. So we divided by our first division here, 10. That change 100 to 10.0 and 3 to 0.3. Okay, and also same thing, 979 to 97.9. Okay, let's continue. In computing 1 over 19, 1 divided by 19, Tirthaji divides 0.1 by 2. So he has changed 1 to 0.1 and he has effectively divided 1 by 10. Okay, instead of doing 1 over 19, first he got a 2 by using this sutra here, 1 more than 1 before 9, which is 2. Then he changed 1 to 0.1 and he started divided 0.1 divided by 2. So he has changed 1 to 0.1, which is effectively divided 1 by 10. That is our first division. We would call it out, they say we are dividing by 10. This is our first division. Let's continue. Tirthaji just start using divide 0.1 by 2. Okay, so he's doing same thing, but no one notices that he divided by 10. Okay? At least he didn't make it really clear. Let's continue. Continue with the same thing. We use proportionality, which is equal to my first divisor, to change a nominal remainder to its effective value, effective remainder. Okay, let's see what. Okay, and Tirthaji sticks remainder to the left of the quotient digit. Thus, he effectively multiplies the remainder by 10. 10 was our proportionality when we did 100 over 19 or 3 over 39. 10 was our first division and was proportionality. We multiply remainder by 10. He just sticks the remainder to the left. So he's doing same thing and without recognizing that he's multiplying by 10. Okay, let's continue here. What's going on here? How come Tirthaji is taking so many shortcuts? Skipping details and combining steps is part of VM spirit. Okay? So Tirthaji knows what he's doing and he's skipping details and combining steps is part of the VM spirits. and he's combining, skipping details here. Let's continue here. Can you also do that? Sure you can. Tirthaji knew what he was doing. He had deeper knowledge about VM. He spent 7 years contemplating on the sutras and their applications. Let's continue. When you know what you're doing, go ahead and skip the details. Okay. So, but I have to show you the details so that you know what's going on. Okay. Uh, Tirthaji can skip the details because he knows what's going on, and he knows he can skip the details and still get the results. Okay. Uh, at least in this chapter of the reckoning number, he didn't tell anyone what these steps were. Okay, what the details he was skipping over. Let's so let's con so let's compare continue with the same comparing with reckoning numbers. Let's continue here. Why did I show you the details? I have to show you the details so that you know what is going on. So you have to know the details so that you understand and don't start asking questions. Hey, why did you do that? And why did you do that? And why did you do that? Okay, let's continue here. Okay. So I don't believe that these details are available anyplace else yet. The ones I just shown you, I don't believe they are available anyplace yet. And at least the Vedic math books I have seen, I have not seen such details. In computing reckoning number, we are using same method as Nikhilam method division, and we are using proportional base. In reckoning numbers computing, we use the Nikhilam method of division for proportional base. Okay, continue. I will encourage you to look at reckoning numbers chapter in Tirthaji's book and benefit from his insight. If you are uncomfortable at this time, that's fine too. Then you can skip. Okay. Okay, let's continue and do some exercises now. Okay. First exercise 59 divided by 49. Next 72 divided by 29. Next 2 divided by 39. Next 35 divided by 49. Next 85 divided by 29, and some more. Okay, now we would look at an example of 126541 divided by 88. Okay, let's see what's going on here and how do we continue when we have a larger divisor than we had seen before. Okay, so example is 126541 divided by 88. Let's continue here. So 88 is my divisor here. I would use a base number of 100. 100 is natural base number. Its deficiency of 88 from 100 is 12. Okay, you can get 12 from 88 using R from 9 and last from 10 sutra, okay, which is a Nikhilam sutra. Let's continue. We would use two-step division. We have been talking about all times in this method of division, which is the Nikhilam method division. We would use two steps division. 100 is equal to 100 times 1. 100 is my natural base number, and 1 is the other factor of the base number we just chose. Proportionality would be 100. That's my first division. Okay, let's continue. So this is where we set up the problem here. 1, 2, 6, 5, 4, 1. That is my dividend, and this is my divisor 88, and 12 is my deficiency of the 88 from the chosen base. Let's continue. So we first thing we do is divide by 100. Let's see what, okay? Divide by 100, just like I said. First thing we do is divide by 100. Then we do divide by 1 and make adjustments. Continue. So we just did. When I divide 1, 2, 6, 5, 4, 1, I got a 1 by 100. I divide that. I got a 1, 2, 6, 5, remainder 41. Or I got a 1, 2, 6, 5, decimal 41. Let's continue. Continue here. Now we would divide, first dividend digit is 1. We would divide that by second division, which is 1. 1 divided by 1 is 1. Okay. So that gives me 1 here. Okay. Now we have to make adjustments for the deficiency. Okay. Let's continue. So 1 is my quotient digit and 1, 2 is my deficiency. So 1 times 1 is 1. 1 goes in next dividend digit, and 1 times 2 is 2. The 2 goes under next dividend digit after that. Let's continue here. So that I got a Adjustment for deficiency is 1 times 1, 2 is 1, 2. Okay, so let's see how do we adjust that. 1 here and 2 here. So next dividend digit is 3. We would take over from here, from 3. 2 plus 1 is 3. Stop it. Okay, now we had done so far, got one quotient digit and deficiency, because of that is 1 and 2. So now 2 plus 1 is 3. And now we divide 3 by my second division, which is 1. So we divide 3 by 1 and we got a 1 here. Okay, so 3 here. 3 divided by 1 is 3. Okay, let's continue. Now we have to make adjustment because of deficiency here. Okay, let's continue here. So 3 times 1 is 3, 3 times 1 is 3, and 3 times 2 is 6. Okay, so I got 3 here, 3 times 1, and I got 6 here, 3 times 6. So next dividend position is 6 plus 2 plus 3. I got 6 plus 2 plus 3 is 11. So we would divide 11 by 1. 1 is my second division. Continue. So we would divide, next working dividend is 11. I would divide that by 1. Okay. So we just did. In this position, my quotient value is 11. In this position is right under 6 plus 2 plus 3. My quotient value is 11. Let's continue. Adjustment for deficiency is 11 times 1 is 11, and 11 times 2 is 22. Okay, so we will have these adjustments here in next dividend digits. Okay, in this position of dividend position is adjustment due to deficiency is 11, and the next one is 22. This is adjustment due to deficiency. 11 was a coefficient, and the two digits in deficiency were 1 and a 2. 11 times 1 is 11. 11 times 2 is 22. Let's continue. So next dividend is 5 plus 6 plus 11. In the next dividend position, I have a 22. So I need to divide 22 by 1, which is my second division. Okay. Okay, I got 22 here. Now I have to make adjustments due to the deficiency here. Okay. 22 times 1, 22 times 1 is 22, and 22 times 2 is 44. So my next two adjustments are 22 and 44. Okay, 22 here and 44 here. Okay, now we are in the remainder section here. Okay, and we don't divide anymore in the remainder section. We divided first when I divided by 100, and after that I don't divide anymore, but adjustments we already got in here. So we would just need to add up, resolve the carries on the left, on the quotient side, and add up the remainder side and resolve any improper fraction that might come up. Okay, let's come up. So in the remainder side I have 40, this is 40, plus 220 plus 220, plus 1 plus 4 plus 44. So 40, 220 plus 220 is 440, 440 plus 40 is 480, 480 plus 44 is 524, plus 1 is 525. So this is 525. I have remainder 525. Okay, let's continue. So we had a remainder of 525, and on the quotient side we had a 22 here, 11 here. So we need to resolve the carries on the left. Okay, let's try to resolve carries. So I got 2 here, and this 2 of the carry get added to the 1 in the next position. So that becomes 3. 2 plus 1 is 3. Now this 1 here get added to the next quotient position. So 3 plus 1, 3. The 1 plus 3 is 4 now. Okay, and there's no carries here, so we get a 1 here. Okay, let's continue. So I got at this stage we have a quotient is 1432 right here, and remainder is 525. That's too much of a remainder for division by 88. That means I would have an improper fraction. Let's try to see what we do here. We resolve the improper fraction of 525, which is this one, divided by 88 in the remainder to get a 5 remainder 85. 5 remainder 85. You can subtract groups of 88 also from here. Okay, so let's continue. That means if I add 5 of this quotient here to the other quotient 1432. I got 1437, and remainder is 85. So I have 126541, which is 126541, divided by 88 is 1437, remainder 85. Let's continue. Another example here. Example this time is 98765 divided by 89. Let us see how it's going to work out. Okay, example is 98765 divided by 89. As before, I am going to use a base number of 100, which with deficiency of 11. Deficiency of 89 from 100 is 11. Okay, and as usual, I would use the two-step division, which is 100 times 1. 100 was my base number I'm going to use, and I would divide first by 100, then by 1, and in second division I would make all the necessary adjustments. And proportionality is 100, which is the first division. Let's continue here. So this is how we set up the problem here. Dividend, divisor, and the deficiency. First thing we would do is divide by 100, the first division. Let's see what happens. When you divide by 100, divide by 100. Okay, let's continue here. We just did. Now decimal point is here. Our remainder is start from or to the right of here. Okay, so this is I divide 98765 by 100. I got an answer of 987, remainder 65. Let's continue. Now next we would have to make it divide by 1 and make the adjustments. Let's continue. We divide first dividend digit, which is 9, by 1. Okay, let's continue. Okay, so we get 9 here. Now we would make some adjustments due to deficiency. That deficiency is 1, 1. So let's make adjustments now. 9 times 1 is 1, and 9 times 1 is 1. 9. 9 times 1 is 9, and so is 9 times 1 is 9. So because of this 9, I get adjustments of 9 on the second column and 9 in the third column. Let's continue. So that's what we got. 8 plus 9 in this position, and 7 plus 9 in the next position. Let's continue. So next dividend digit we would divide by 1 again. 9 plus 8 is 17. So my quotient digit is 17. Okay. Quotient value in this position is 17. Okay. So now again we would make adjustments due to deficiency. Okay. 17 times 1 is 17, and 17 times 1 is 17. Okay, let's continue. So I got my adjustments here. So in next dividend position, 7 plus 9, 16 plus 17, 33. I have 33. Okay, let's continue. So I have 33 here. I would divide 33 by 1. 1 is my second division. Continue. Next dividend position, I would divide 33 by 1. Okay, so I got 33. Now I had to make adjustments due to deficiency. 33 times 1 is 33, and 33 times other one is 33. Okay, adjust for deficiencies. I got 33 here and 33 here. Okay, now we are in remainder column here, and we do not divide anymore. We divided in the remainder column. Very first division by 100 got me a remainder and quotient. Quotient we divided again, but remainder I do not divide anymore. Okay, let's continue here. So we got remainder here. Intermediate quotient is 900 plus 170 plus 33, which is 1103. So far, when I resolve the carries on the left, on the quotient side, I got 1103. Let's continue. So I got 1103, and remainder I got to compute what's in here, what's in the remainder side. So this is 60, this is 170, this is 330, this is 5, this is 33. 170 plus 330 is 500. 500 plus 60 is 560. 560 plus 33 is 593. Plus 5 is 598. So 598. In the remainder side, I have a 598. 598 is not more than 89. So we have to divide that again. 598 by 89. Either use the method we just did or do something else. Let's continue here. So this give me a improper fraction. Improper fraction is in the remainder 598 divided by 89. Let's continue here. So resolve the improper fraction of 598 divided by 89. I get 6 remainder 64. So get 6 remainder 64. It's kind of, okay, it's kind of close to, if you had 600 here and I divide it by 89, so from each 100 I take 89 out, I got 11 left. So if you had 600, remainder would be 66, but it's 598, so remainder is 64. It's 6 remainder 64. So I'm going to add 6 is a quotient to the other quotient I have. Now we can repeat method. We can also, instead of what we just did, you can also use the method we did before, like this here. Divide by 101 and once, and then by 1 and adjust. Okay. Let's continue here. So I have answer of, when I divided 98765 by 89, I have 1109, remainder 64. We did have some larger numbers in the quotients here, 17 here, 33 here, and there were larger numbers in the adjustments values here. Okay, so but we the same but the method worked if you were careful enough to ensure that this 33 is a value in one position and 17 is a value in one position. Okay, let's continue here. We do that same problem again, and time I will use a base of 90. 90 is 1 more than 89, deficiency is 1. 90 is not a natural base number, it is a proportional base number. Okay, let's continue here. So two-step division again. 90 is equal to 10 times 9. First division is by natural base number, which is 10. Second division is by the other factor of the base number, chosen base number. And we make any adjustments due to deficiency or otherwise in the second division. Okay, let's continue here. Problem 98765. As a divisor 89, deficiency is 1 from the chosen base of 90. Let's continue. First we are divide by 10. That's what you said. We would divide first by 10. We divide first by 10. Let's continue. We just did. So when I divide 98765 by 5, I have a 9876 remainder 5. Okay, that's what this line did. Okay, and this is what we did, divide by 10. Okay, let's continue. That's my first division here. Now we have to divide by 9. My second division is 9. So I would divide this dividend digit position by 9. So I got 1. Adjustment due to 1 is this one is the deficiency times dividend position. Adjust for deficiency, so I got 8 plus 1. I got 9 here now, in second position here also, 9. I divide that by 9. I got 1 here. That gives me adjustment in the next column of 1. Adjust for deficiency, got a 1. Let's continue. Let's continue. So far in the previous slide, we have computed that from this 9 here, I got a quotient of 1. That gives me adjustment due to deficiency of 1 in next dividend column. So 8 plus 1 is 9. Divide that by 9, get a 1, and this adjustment here 1. Now we have to divide in this column where I have a 8 here. 7 plus 1 is 8. Let's continue here. Now in the next dividend position, I have 8. 8 divided by 9 is 0, remainder 8. Let's see what we do. So I get 0, 0 here, and I have a remainder of 8. Okay. So 8 is a from second division. That's a proportional. Let's continue. Adjustment due to deficiency is 0. Quotient is 0. 0 times 1 is 0. And to the remainder, it's proportional. 8 times 10 is 80. So we would add 80 to the next dividend position here. We just did. Okay. So 6 plus 80 is 86. Let's continue. Now divide in next column. 86 divided by 9 is 9 remainder 5. 9 remainder 5. Okay. So now there are adjustments due to 9, which is 9 times 1 because of deficiency, and also because remainder. Remainder is proportional. Proportionality is 5. 5 times 10 is 50. So we have to make adjustment of 50 plus 9. 9 from the quotient and 50 from the remainder, okay, in the next dividend position. So adjust due to deficiency is 9 times 1 is 9, and that due to remainder is 5 times 10. 10 is my proportionality, and its division by 9 is my second division, so 50. Okay, so I get 59 here. Okay, let's continue. Remainder is 64. 5 plus 59 is 64. Okay? And that is less than 89. 64 is less than 89, and fractions would be proper. So I got a 98765 divided by 89 is 1109, remainder 64. That's the same value we got before, but now we don't have a larger value is in the quotient digit. I did have one larger value in the adjustment position, and also one here for adjustment positions. Other than that, we were able to keep single digit numbers here. Okay? There are all single digits in the quotient column here, and the quotient row here, there is all single digits. Okay, let's continue. So that means that 98765 divided by 89 is 1109, remainder 64. 1109, remainder 64. Let's look at same example again. Our Kent R. Williams suggested that we can change 98 to 100 minus 2, or 10 bar 2. Okay, this is negative 2 here. Now dividend is 10 bar 2, 765. This would ease the large quotient digit problem. Okay, this change would ease large quotient digit problems we had with when we use a base number of 100. Let's continue here. So this is the problem now. Okay, you have seen the negative numbers in subtraction video, and which is this video here, and so you go ahead and explore the suggestion, and a teacher can also do that in the class. And if there's still some issues and you're in my class, we'll go ahead and work this out. Okay, let's continue. Let's do this example here. 121,985 divided by 887. Let us continue. So example is 121985 divided by 887. Let's continue. We would use a base number of 1000, which is more than 887, close to 887, and slightly larger. Deficiency is 113. 113 is 113 is the deficiency of number 887 from the base number 1000. Let's continue. We would do two-step division again, with 1000 being our first division and 1 our second division, and proportionality is 1000. We would first divide by 1000, then divide by 1 and make any adjustments due to deficiency. Let's continue here. We set up the problem like that. 121985, that is my dividend. That's this number here, and that's this number here. Okay? 887 is my divisor, and 113 is my this 113 is my deficiency here. Let's continue here. First thing, we would divide by 1000. Okay, that's my first division, and after that we would divide by 1 and make any adjustments. Okay, let's continue here. Divide by 1000. Okay, what do we do? Just draw a line to the left of 3 digits here. We just did. If I divide 121,985 by 1000, I have 121, remainder 985. Okay, let's continue. Divide first digit by 1. This is 1, so we divide that by 1. I got 1 in the quotient digit. So I got first quotient digit is 1. Okay, let's continue here. Adjust for deficiency. There are 3 digits in deficiency, 1, 1, 3. So 1 times 1 is 1. 1 times 1 is another 1. 1 times 3 is 3. So we would just go apply the. So this is my first quotient dividend adjustment. This is my second adjustment digit. This is my third digit of the adjustment. Okay, let's continue here. Now next column we have a 2 plus 1. So we have a 2 plus 1. Next column, that's 3 plus divided by 1 is 3. We divide 3 by also by 1, which is my second division. Okay, so we get 3. Now make adjustments because of a deficiency. That would get me 3 adjustment here and 3 in the next column and 9 in the column over here. Okay, let's continue. So make adjustments. 3 times 1, 3 and 3 times 3 is 9. So 3 times 1 is 3. 3 times 1 is 1. 3 times 3 is 9. So here's my adjustments now. Okay. Now we have to divide in this column here. We have a 5 here. 1 plus 1 plus 3. And we are going to divide by that by 1. 1 is my second division. Let's continue here. So we divide 5 by 1. I got 5. So this is my 5. Now I have to make adjustments for deficiency. The quotient is 5 and deficiency have 1, 1, and 3. So my adjustments are 5, 5, 15. Let's continue here. 5 times 1 is 5 and 5 times 3 is 15. And let's do the adjustments now. So this is my adjustment here. 5 in this position here, 5 again in this position here, and 15 in this position here. Okay. So okay, we are done with divisions. We are now in the remainder column, and we don't divide remainder column anymore. We divided that by 1000, and this was my first remainder. Now we don't divide the remainder anymore. We just got to add the numbers in here we got. Okay, let's continue here. Remainder is 900 plus 300 plus 300 plus 500. Okay, plus 80 plus 90 plus 50 plus 5 plus 15. Okay, so here 300 plus 300 is 600. 600 plus 900, 1500. 1500 plus 500, 2000. 2000 plus 80 plus 80 plus 90 is 170. 2000 plus 170 is 2170. Plus 50, 2220 plus another 20. So that's 2000 plus 240. Okay, it's 2000 here and 170 plus 70 again, 240. 2000 plus 240 is 2240. So remainder is 2240, and which is a lot more than 887 is. So we would have an improper fraction again. Okay, let's continue. Subtract groups of 887 from 2240. 2240 is 1774. That's two groups plus 466. Yes, so that means this thing have a two more groups of 887. That would give me quotient of 2. I have quotient of 2 more. So that gives me 137. 135 plus 2 is 137. The remainder is 466. So I have, when I divide 121985 divided by 887, I've got 137, remainder 466. So we were able to divide by 887 in these 3 lines here, and there is no divisions because when we divide 1 by 1, it's just bring down this digit here. There are only multiplications to compute these deficiency adjustments, and there are additions here. So we had basically we did that by additions. We were able to divide 121985 by 887 by additions here. Okay? Additions of the adjustments due to deficiency. Let's continue. Example here. Example is 1519851 divided by 5897. Okay, let's continue here. Example we would take is 1519851 divided by 5897. Let's choose a base. Base number is proportional base number with 6000 and deficiency is 103. Deficiency of 5897 from 6000 is 103. Let's continue. And two-step division again. 6000 is first division is by base number, which is 1000. Second division is by the other factor of the base number, which is 6. 1000 times 6. Okay, we would divide first by 1000 and then by 6 and make adjustments on after the second division. Let's continue. Okay, number is 1519851. Okay, first thing we would do is divide by 1000, or first division. So we divide by 1000. This is what it is. When I divide 1519851 by 1000, I get a 1519, remainder 851. Decimal position would be here, and remainder would be to the right of this line here. Okay, continue. So I have to divide by 6. I choose this first two digits 15. 15 divided by 6 is 2, remainder 3. So let's write down at least the quotient we have 2. Remainder is 3, and let's see what the adjustments are. Adjustment for the deficiency is 206. So I got 2 here, 0 here, and 6 here. And that due to remainder is 3000, but only adjustments only go next 3 digits, which is because there are 3 zeros in the 6000 and 3 zeros in 1000. So the adjustments go in next 3 digits. So the total adjustments is 3000 plus 206, 3206. Let's see how it goes. This is how we apply this thing. And very first column I got 32 adjustment, next is 06. 3000 plus 206 is 3206, and adjustment to the remainder goes is high, more than 206. As a matter of fact, it's a order of magnitude higher. So 3 times 1000 is 3000. So this is 206 and this is 3000. Or you can do in 2 lines if you care to. Do 206 in one line and 3000 in the next line, and within the same 3 digits though. Okay, let's continue. Okay, we had so far 2 here because we divided 15 by 6, 2 remainder 3, and these are the adjustments. 206 from the 2 and 3000 from the remainder. Let's continue. Now I have a 33 here. 1 plus 33 in this dividend position, give me 5, remainder 3. Okay, so I got 5 here. There are 2 adjustments. One because of this 5 here, which give me 5, 0, and 15, and which another one is because 3 here. 3 times 1000 is 3000, and they give me 3000 here. 3 to the left of this column and 3 zeros. Okay, let's continue. Adjustment for deficiency are 5, 0, 15, and remainder 3000. Let's continue here. So that's what we got. 3000 for the remainder and 5, 0, 50, and 15 for the quotient digit 5. In this column here, we are in this column here. I got 9 plus 35, which is 44. Okay? So I have to divide 44 by 6. I got 7, remainder 2. Let's see what happens. 7 quotient. Now we have to make adjustments because of 7 and also because of 2, remainder. Okay, let's continue. Adjustments are, because deficiency it is 7, 0, and 7 times 3 is 21, and remainder is 2 times 1000 is my first proportionality. Okay, 2000. So this is what, so we got a total is 2000 and 7021. 2000 plus 7021. Okay, now we are done division because we are in the column on the right here, which is the remainder section, and we do not divide in remainder section again. We divided first by 1000, and this was my remainder section, and we do not divide again, okay, in the remainder section. So remainder is 800 plus 600 plus 2700 plus 50 plus 150 plus 1 plus 21, which is equal to 4100. 800 plus 600 is 1400 plus 2700 is 4100. So 50 plus 150 is 200 plus 22, 222. So it's 4322, and 4322 is less than 5897. So 4322 would make a proper fraction, and so answer is 257, remainder 4322. Let's continue. So this is where, okay, that means I have an answer of 1519851. That's this number here, and this number here divided by 5897. I have a 257, remainder 4322. Let's continue. Let's go analyze that problem we just did. What 1 5 1 9 8 5 1 divided by 5 8 9 7. Okay, this is our problem. This is how we did it. We said that in the end 257 was a quotient and 4322 was remainder. Let's continue here. So if I look at the very first division we did was 15 divided by 6 to get 2. There was no adjustment in this column here. No adjustment for deficiency in dividing by 15 over 6 we did in this column here. Okay, let's continue here. One adjustment for deficiency in dividing 33 divided by 6. 33 divided by 6 we did in this column here. And there is a one adjustment for deficiency and one for remainder. Okay, one for deficiency, another one for remainder. Let's continue here. The two adjustments for deficiency when we did a 44 divided by 6. We did 44 divided by 6 in this column. So there are two adjustments for deficiency, 0 here and a 5 here, and one adjustments for the remainder here. Okay, let's continue here. There's three adjustments for deficiency in the next column. So in this column we have three adjustments for deficiency, which is 6 here, 0 here, and 7 here, and this 2 is for the remainder from the previous division. Okay, let's continue here. Two adjustments for deficiency in the next column. There are 2 here, 5 and a 0. This one is now it's 15 and a 0. 15 and a 0. Okay, let's continue here. Does that remind you of vertical and crosswise multiplications? One column, one product, two products, three products, then two products, then one product. Yes, it is, and we are emulating straight division. In straight division, we use vertically and crosswise. Let's continue. Okay, so this is what we had. In this method of division, we are proactive. When we do a Nikhilam method of division, we are proactive. We apply corrections as soon as we know of those corrections. When we did 15 divided by 6, we applied all the corrections. When we did 15 divided by 6 to get that, there are three corrections applied. 2 here, 0 here, and a 6 here. Okay, 2 times 1, then 2 times 0 here. 0 is the 2 times 0 is a 0. 2 times 3 is a 6. Okay, let's continue here. In straight division, we apply these corrections when needed. When we are dividing in a column, we first apply the remainder, then multiply the quotient digits 2. That's quotient. When we are in this column here, we quotient digit 2, that's the quotient digit to the left of this column here. Okay, with the first deficiency, there's only one digit here, so we multiply that with the one digit of the deficiency, and apply corrections and then divide. So okay, so what we did in straight division, we'll say come in here, 3 is the remainder, so we apply that. Okay, then we say okay, how many quotient digits left? There are 2. One digit number is 2, so we multiply that one with the one digit of the deficiency, and that's my adjustment in this column for the deficiency. This is my adjustment, one adjustment. There was one digit to the left of this column, one quotient digit to the left. Okay, let's continue. And this is what we did. So we had 2. We only had one quotient digit 2, and none of them are. So this is the only multiply we did. Okay. All right. 2 times 1 is 2. That's what this is. I go vertical and crosswise from here. First division, we use only one column here. Okay. Now we are next column here. When we did a 44 divided by 6. Okay, so this is what we have, 46 divided by 4 here, and we apply correction for the remainder. Okay, first this 3 is a correction for the remainder from the previous column. This 5 and 0 and 15 are corrections due to deficiency. For deficiency correction, we multiply two quotient digits, this 2 and a 5. We are in this column here, there are two digits to the left, 2 and a 5. With the two leftmost two deficiency digits, so we multiply those with 1 and 0. Okay, so let's set up the problem here. So we're trying to compute the second product here, and from the left, we are starting from left here. So we did one product here already to get 2 here. Now we need to get this product here. Okay, so we get a 2 times 0 is a 0, and plus 5 times 1 is 5. So that's what our 5 is here. Let's continue. For next column, we have a 3 quotient digits to the left. So when I come in this column here, there are 3 quotient digits to the left, 2, 5, and a 7. And we apply the remainder first. Okay, and we don't divide in the remainder sections. So let's set up the problem again here. So for this column here, one column after the dividing line here, okay, we have a 257 in the quotients and 103 in the deficiency. So we multiply them all out. 2 times 3 is 6. That's the 6 here. 5 times 0 is a 0, and that's 0 right here. 7 times 3 is 21. No, hold on. 2 times 3 is 6. That's 6 here. 5 times 0 is 0. That's 0 here. 7 times 1 is 7, and that's this 7 here. So we applied 3 adjustments due to deficiency, and they all came from this vertically and crosswise. Okay, let's continue. This is our solution of the problem. Now we are in the remainder section, and no more division. We have used all the columns. We start to drop the columns off. So this is the situation we had, 257. Okay, this is what we had, and that's the numbers we use here. 2 times 3 is 6. 5 times 0 is a 0. 7 times 1 is a 7. Okay, now we are in this column here. There are only, when look at 3 columns to the left, this is not a quotient, and this is a quotient digit, and this is a quotient digit. So we have 2 quotient digits on the left. Okay, means out of 3 digits, the rightmost 2 digits are left. We can use here. Number of 3 digits I got is from number of zeros in our divisor, our base number. Base number was 6000, and 6000 has 3 zeros, and only there are 3 digits here, and only 3 quotient digits can be used in up to 3 digits in computing these deficiencies here. Okay, let's continue here. So we just drop this column off, 5 and 7 left. So we apply 5 times 3 and 7 times 0. Continue. Oh yeah, 5 times 3 is 15, and 7 times 0 is 0. So these are my 2 deficiencies in Nikhilam method. We applied these already. As soon as we got this 5 here, we applied this deficiency. And proactively in straight division, we would apply when we are at this column. For next column, we drop another column from the product of quotients and deficiencies. So when we are in this column here, look back, this column has no quotient, this column has no quotient, and this is the one that has some quotient. Okay, so we would apply 7 is the rightmost digit of the quotient. So we would apply that with rightmost digit of the deficiency. Okay. So we got in here 7 times 3 is 21, and this is 21 right here. Okay. So, and that is what straight division is. And straight means In Nikhilam method, we apply the deficiencies proactively, and in the straight division, we would use those adjustment due deficiency when we have at the time we need to use it. Let's continue. Exercises now. Okay. First exercise 117,949 divided by 95. Next 125366 divided by 89. Let's continue. 102736 divided by 84, and then some more. Do you care for some more examples? I see. To see how I use this method to divide by 999 to compute 1 over 998001, please refer to this video here, possibilities with Vedic math, and this is my link to that video. Okay, let's continue here. I have shown you the concepts, methods, and details, and some examples. Okay? Please feel free to explore Tirthaji's book for more examples. Okay, let's continue. And a teacher can take up more examples in a class, and I would, in my class, I would try to do the same thing, take up some more examples. Here, this method gives you alternate way to divide. So this is an alternate way. We didn't divide. If you stay with the natural based numbers, there's no division, because you can say division by 1 does not change the result. Quotient is equal to dividend. Okay, so if you stay with natural based numbers, there is no division. So no division when you stay with natural based numbers. Okay. The video introduces the concept of two-step division and proportional remainder from the second division. The video relates Nikhilam method to one used in computing recurring numbers. We computed recurring numbers using Nikhilam method and proportional base numbers. Continue here. We have also seen that the method emulates straight division. In Nikhilam method, we apply adjustments due to deficiency proactively as soon as we know. In straight division, we apply the adjustments due to deficiency when we need them. Adjustment due to remainder gets applied right away in either method. Let's continue here. Is it easy? That's subject to interpretation. In this method, we need to remember multiple corrections, and it does not suit for one line mental solution. Okay, so this is not good method for one line mental solution, but it's an alternate method, and you can divide most of the time you can divide without dividing, by adding only. It's mostly adding if you stay with natural base numbers. For example, the teacher's manual is a reasonable reference for and has some examples, and most examples would be in Vedic Tirthaji's book. Okay? And Glover's book also have this Nikhilam method, and Vanna Singh's book also have touches on Nikhilam method. That's all.